Hi, welcome back. Microprocessor online class. So this is exercise number 3 in section D. Count zeros in a block. Before that, how to copy a block. So how to reverse a block. Then sum of blocks. These things are already done in the previous section. Now count number of zeros in a given block. First we create one block, that is for C080. This is known as beginning of a block. From the beginning of a block, which is pointed out HL register, that is HL start of block. Then end of the block is C087. So totally the length of the block is 8 bytes. So C equal to 08. That is the length of bytes, length of block. Then our aim is to count number of zeros in a block. So B equal to 00. At the initial level, the B register is 0. The purpose of B register is to count number of zeros in a block. Okay, whenever the block data will be 0, that is a byte will be 0, it incremented, that is B is incremented by 1. There is a condition for if m equal to 0, for the content of memory equal to 0, then it immediately the B register is incremented, that is B equal to B plus 1. That is the condition. Or if not 0, the content of memory is it could not 0, then it incremented by HL register, that is HL plus 1 for indicating the next content of block. Simultaneously, the length of block will be decremented by 1 because it is move on the next pointer. The memory pointer will move on next data. It is the next content of block, so it will be decremented. So these steps will be executed repeatedly as long as C is not equal to 0. That is, at the initial level C equal to 8. Whenever it reaches 0, then go to next for store B. How many zeros are currently presented in block, that is to be stored in B register. So then it finally end the program. So here one block is there for C080 23, 81 for 0, 82 for 34, 83 for 0, 84 for 12, 85 for 33, 86 for 0, C087 for 55. So there are 8 blocks, only the 3 zeros are there, so it will be counted. So this is our algorithm for count number of zeros in a block. Now I got to explain how it's working. This is 8085 simulator. First of all, I create a block for LXI H, C080. This is our beginning of a block. Then move immediate C, 08 for length of block. That's totally 8 bytes. Then move immediate B, 00, 00. This is for 0 counter for counting how many zeros in a block. Then again, this is our label for executing repeatedly some of instructions. The first move A, M, that is content of memory move on to accumulator. So currently the memory pointer HL is pointed to C080, so that is move on accumulator. So after that it compare immediate 00 for comparing both content of accumulator and 00. If it is equal, so the B register is incremented, or it is not 0, that is jump no 0 for another label for indicating the program sequence go to no count. Okay, or it is 0 means for incrementing B, no 0 means for go to the label name no count for incrementing memory pointer, that is HL register is incremented. Simultaneously decremented by C by 1, that is 8 minus 1 is 7. Then the condition is executed repeatedly as long as the C register becomes 0. So when it reach C 0, then go to next line. For move M comma B, that is B register, the content of B register is move on memory, then it's stored. Okay, then you stop the program. Now go to assemble it. So it is executed. After that, the mnemonic hexacode bytes are created. Then I create a block. Then go to store directly to specified memory location. Here I give the block for C080 is a beginning of the block. I give the data is 23. Then C081 for 0. Then C082 for 34. C083 for 0. C084 for 12. C085 for 33. C086 for 0. Finally C087 for 55. So now the blocks are created. Then go to show entire memory content. Here your blocks are created C080 to 87. Now go to execute step by step. First it forwarded C080, that is LXI, for store the indicating the memory pointer indicating the first data, that is 23. The next it forwarded the 23 is move on to accumulator. After that it compare the immediate data. So both are equal, the B register is incremented. It could not equal, then it decremented by C, then memory pointer also incremented. Here you see that it is not a 0, that is a 23, so it could not incremented by B, and simultaneously the memory pointer is incremented for C081 for 00, then it decremented by 1 by C, so 8 minus 1 equal to 7. Now the 0 is moved on to accumulator for comparing both content of accumulator and immediate data, so both are equal. Now the B register is incremented, so incremented by 1, B register is incremented. So these steps are executed repeatedly whenever the C register is reach 0. Okay, so repeatedly executed, and simultaneously 0 counter is incremented, that is a B. Now the C is 0, then go to next line. After that the finally the number of zeros is move on to memory, that is C088. So this is for simple exercise. Try yourself after watching this video. Okay, thank you.